Students, we were discussing the numericals from your section waves, and right now we will start the numericals from your beats section. Okay, this beats you will get it in your chapter superposition of waves in your book, but you will also check it. Okay, so let's start the first sum from your beats part. The sum is a tuning fork originally in unison with another tuning fork of frequency 512 produces 5 beats per second. So condition A is when a little wax is attached to it, and condition B is when it is filled. You have to calculate the frequency in both the cases. You have to find out the value of your frequencies. Alright. So students, for this part, what is the thing given? That a tuning fork whose frequency is to be found out, that is given, and it is attached to another tuning fork of frequency is given, that is 512, and it can produce 5 beats per second. But your original tuning fork in part A is attached to a little wax, that means little wax is attached to it, and in part B when your tuning fork is completely filled. Alright, so students, let's start this part A, that I'm writing here, part A. So students, when a little wax is attached to it, what will happen to the frequency? That your changed frequency or your altered frequency will be less than the original frequency, isn't it? It's very natural, and we have discussed this in your theory classes. That means when little wax is attached to it, that altered frequency will be less than that of the original frequency of the tuning fork. That means original frequency means what? Before attaching the wax on the tuning fork, it has some frequency. So your altered frequency will be less than that of that original frequency. Okay. So your altered frequency, students, I am denoting is by N2. Okay. And your original frequency, I am writing it as N1. Okay. So yes. So see, in the question it's given that tuning fork, that is the frequency whose frequency is known, that tuning fork's frequency is 512, and it can produce 5 beats per second. So therefore your N1 minus N2 will be your 5, because it can produce 5 beats per second, isn't it? So you have to find out this N2, isn't it? That is the change frequency. This you have to find out, because N1 is already available in the question. So your N2 will be what? N1 minus 5, that is 512 minus 5, that is your 507. Okay, hertz. That means N2 you have got. What is the N2? That when a little wax is attached to it. Okay. Now find out the value of B. What is the B given? When it is filled. That means when it is completely filled, that means that tuning fork, that altered frequency you have to find out. So generally, students, when the tuning fork is filled, your altered, that means your change frequency will be always greater than your N1. Okay, that means it will be always greater than your original frequency of the tuning fork. Okay, what is that condition? When it will be completely filled. Okay, so I am writing here, students, altered frequency. I am writing in short, N3, and your original frequency is N1. I am not writing it again. Okay, and for this, your altered frequency, students, that I am writing N3 will be always greater than N1. Okay, and for this N2, for part A, your N2 is always less than your N1. Okay, you can check it out. your n2's value you're getting 507. It is less than 512. Yes, so it's matching our condition. So now let's get back to this part B. So your n3 minus n1 is your 5, isn't it? Because that tuning fork whose frequency is known, it can produce 5 beats per second. So you can write this. Alright. So n3 will be equal to 5 plus n1, that is 5 plus 507, isn't it? 5 plus 512 is equal to 517, isn't it? Hertz, isn't it? So our sum is done. Repeating it for the last time, what is the turning point of this particular sum? Part A was what? A little wax is attached to it. So when this thing will be written, that when little wax is attached to it, your change frequency will be always less than your original frequency. Okay, this is the main condition. Okay. And what is the next turning point? That when it will be completely filled, that means part B, it will be always greater than your n1. This is your condition, that is your turning point 2. Alright. So yes, so we have done this, and since the beats value is given, okay, and your n1's values is given, n1's value is also given. So yes, you can able to find out these two frequencies, which is the main equation you have to follow. For the part A, n1 minus n2 will be equal 5, and you have to find out this value of n2. And for the next part B, your altered frequency I've denoted it by n3. So since the equation that is given, that is the information that is given, that it can produce 5 beats per second, so n3 minus n1 is 5. Alright, and from here just find out the value of n3. So we'll get your altered frequency for your second condition, that is when it is completely filled. Alright. And students, one thing, and for this numerical we have covered in today's class, but in your book one theory is also given. We have done that theory in class also, isn't it? That theory was that tuning forks are given. Alright, one experiment you can see, and the one's value is given and another tuning fork's value, you have to find it out. The theory also you can get it from your book.